Okay, number 12, various functions are shown. Sketch the graph of the derivative on the same axes. So key idea to use, this looks like a parabola. Look at the max or minimum value. Little relative max and mins will tell you that the derivative is 0. So I know that my derivative is 0 there. Then if you think about these tangent lines, these are all positive and increasing, whereas these over here are all negative and increasing as you move to the left. So our derivative is going to look like that, right? It's a positive x squared, which means we're going to get a positive linear function. Okay, what about this thing right here? Well, notice it is a positive linear function, which means its derivative will be a positive horizontal line at the y value of whatever the slope is. Okay? C, piecewise, first thingy, starting from the left, we need to figure out the slope of this function. Maybe that's hard to do, but I have faith. Kind of look like that lines up right there. Looks like we have the point 1, 2, 3, 4, 5, 6, so -6, comma, -2. And we have the point up here, -5, comma, 1, so it's telling us our slope is a positive 3. Which means if I'm graphing the derivative there, it needs to be a positive 3. So I'm going to do this over like that. That should be a horizontal line at the y value of positive 3. Next, notice we have a flat line, which means it is just straight up going to be, flat line is 0, because the slope of a flat line is 0. Next, we have a normal parabola here, which means its derivative is 2x, which means boom, 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 right there. That's the equation, y prime equals 2x. Finally, last piece, what is the slope there? Let's see, we go down 1, 2, 3, 4, and over 1, 2. So it looks like our slope is -2. And so we get this right there, like that. Piecewise function with a piecewise derivative. Okay, this thingy, mark all of those relative maximum or minimum values. Those are all going to correspond to zeros on the derivative function. Then just think about positive or negative. Well, to the right of that rightmost x-intercept, our graph is decreasing, right? So its derivative is negative. All those tangent lines are going to be pointing down and to the right. Well, in between those to the left, all those are positive, right? It's increasing in that interval. And then again, decreasing there and increasing again there. So negative, positive, positive, negative, positive, negative from left to right, which means we're going to have something that looks like this, and that should vibe with what we have. We have what looks to be a negative x to the 4th graph, which means we're going to get what looks to be a negative x cubed graph as the derivative. Okay? Almost there. Two graphs that look pretty similar, E and F, that have totally different derivatives. This thing is absolute value of x. What's the derivative of absolute value of x? Well, what's the derivative of this over here? Well, that is just a linear branch right there. So that's going to be like something like that. And to the left, it's going to be the same thing, but negative, because it's going down. And look, we get our mama function, abs x over x. That's been transformed a little bit, but that's what it is. Sweet! Okay, this thing is weird. So let's think about it over here first. If you were to zoom in on this spot, it would actually look exactly the same as what you're looking at right now. It kind of just looks like that. It gets like super, 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 super steep. So steep, in fact, that one might say the limit tends towards infinity. But for us, and what we're doing, we're just sketching this thing. So that's what we want to do. We want to sketch it. I'm kind of bibbling and babbling because I'm standing up from my chair because my butt is sore from sitting down for like 4 hours doing all these videos for all my different classes. So I'm moving to my bed so I can lie down. Probably just should have paused it. Whatever. Okay, so let's look at this. Well, this thing is going to kind of like continue to flatten out a little bit as you go, which means if you think about those tangent lines, they're kind of like getting closer and closer to like zero, kind of flatter and flatter. The farther in we go, it's kind of hard to tell until you get a little closer, but the farther in you go, the steeper and steeper those tangent lines get ad infinitum, forever. So if you think about that, we have a really super positive slope going towards infinity, right? And as we move to the right, the slope decreases, gets less and less and less. So we get something that looks like that. And then on the left side here, it's the same idea, except like all these tangent lines are now negative. So we get kind of like a mirrored version of this same thing, something like that. And you're probably looking at that and you're probably like, oh my gosh, it's the 1/x graph. But it's not, right? It looks a lot like it, but well, who's the mama of this graph? The purple, the original function, well, that's x to the 2/3. So if you take the derivative of x to the 2/3, you get 2/3 times x to the negative 1/3. So really our derivative is actually 2 over 3 times the cube root of x, and apparently 1/x looks pretty similar to 1 over cube root of x.